In my experience, we did encounter fake transistors, and actually they had an original mark. They were even sold, and then we had to go down in the tracing, and then we found, there were even original wafers inside, but they were recycled wafer that didn't pass the test, that were repackaged in second-hand package size.
Would you say that's one of the differences between Taiwan and mainland China, is this attitude of kind of like, in China, it's pretty good enough to sell, whereas in Taiwan, it's more precision?
Again, depends on the people involved. It's
Right.
not about location, it's about the people.
Yeah.
Are the people aware? Are they taking precautions? So for instance, for semiconductors, when you are in a legitimate and long-term business, you all switching components which have a power rating, we buy from authorized distributors. So where the trace back to the original manufacturer is transparent. But then, especially in times of better economics, there are often shortages for certain components in the market. And then you have these traders coming into the market.
The middle.
That's the middlemen that suddenly show up with some components because they understand there's a shortage with dubious origin. And then, but given the real world situation, when an entrepreneur has a choice to wait 1 year for his components of genuine components, or taking a risk and having the stuff in 2 months or 1 month, people will take that risk. Now, that risk, how big is that risk? And that very much depends on how that component is being used, how it is being verified. And we do another one. We have normally we run manufacturing accompanying lifetime tests. So meaning when you produce 1,000 power supplies, you pick 5 or 10 and say, okay, I'm going to run them for a month or 6 weeks. So, and when in this lifetime test, you detect that after 2, 3, 4 weeks, you get an increased failure rate, you still have the choice, you still have the chance to stop the products from entering the market, because they're typically 6 to 8 weeks on a container ship by the time they reach the market. But if you don't select a few, you would not know. And every power supply, in most of our applications, they run at least for 4 hours before they're being shipped out to weed out potential risks, and then you to react. Normally, it's not good to test for quality, because usually you want to design for quality. But then in the end of the day, you hit the realities of the component market. And in my experience, we did encounter fake transistors.
Wow.
And actually they had an original mark. They were even sold. And then we had to go down in the tracing, and then we found, there were even original wafers inside, but they were recycled wafer that didn't pass the test, that were repackaged in second-hand package size.
Wow.
Somewhere in Southeast Asia.
How did you detect that? Was it through your testing?
No, we had a failure rate of 1 to 2%, and when the the defects came back, and you start running through your 5D, 8D quality control process, you identify the root cause of the problem. Root cause was that transistor is failing. We verified the electronic circumstance. They were within specification. It didn't cause a problem. Then we sent the component to the manufacturer. The manufacturer said, oh, your date code didn't exist. Then they removed the package and analyzed the wafer on a wafer level, on the chip level, found, the wafer is genuine, but the package is not. And then we tried to trace back through the agent. I even tried to sue the agent because I had a couple $10,000 damage of this.
Wow.
But the evidence was insufficient, and the agent couldn't know, and then couldn't give a malicious intent, and anyway. The reality of enforcement is a different story again in the city. But what actually happened in the end was that, when the wafer test, they mark out certain chips which are not within spec, then they're cut out. Where do the cut out wafers go? There was somebody making a buck by taking those cut out parts
Yeah.
and repackaging them elsewhere.
So it sounds like these are the big challenges for engineers when you're working together with them. They are responsible for the design,
Yeah.
and then the sourcing part comes into place, and then it's very difficult to detect, for example, this kind of fake components until after the failure, right?
Yes, of course, there are certain things. There are validations. There are logo considerations. The good factories, they have their IQC trained, but there's no 100% confidence.
Right.
And there are even people saying, like, if there wouldn't be recycling and there wouldn't be these so-called fake components, we wouldn't have enough components to meet the electronic demand.
Oh, really?
So this is actually embedded in the industry.
Wow.
Yeah, the reality of it is like this. But how do you design your manufacturing process to make sure that you will not be hit on those critical parts?
Yeah.
I mean, if a resistor is recycled and there's a very low current flowing through it, the risk is very low. But when this is a power switching transistor in the main circuit of your power supply and the bonding wire is compromised because it's been packaged in some backdoor workshop, that's not the quality you expect from a top brand. But the top brand is written on it.
Right. So after so many years in the industry, what methods have you developed at Celinius to prevent, or let's say minimize, the risk of this?
So one of the key criteria that we are doing is that during the sample and pilot phase, we do not ignore failures.
What do you mean you do not ignore failures?
If you have a failure in your production line, say you're producing the first 20 samples, and you have one or two failures, I say, okay, it's just starting now. No. You really understand why did these one or two failures happen. And when you learn during, let's say you run the first 500 pieces and you have them in 4 hours, and out of these 500, you have 2 or 3 failures. Look at these 2 or 3 failures. Don't just throw them in a garbage can. Look at them. Go in understanding what is actually happening there. Mm-hmm. What did go wrong? Why did it go wrong? What can be done to prevent that from going wrong again?
So would you say typically people will just assume, okay, in a set of samples, there might be 1 or 2 failures. That's just going to happen.
Exactly.
Whereas your way is not just to make the assumption that these failures are normal, but rather go in and investigate.
Yes. And this is why we say a failure that happens early, we say it as a gift.
A gift?
Yeah, it's a gift because it gives you the chance to find out your weakness.
Right. Once you detect the failure, what power do you have to then rectify it with your manufacturer?
That depends. It's not a black and white question. Yeah. If the component is a failure, then you may want to replace that component, but you don't know whether the replacement component is necessarily much better than the one that you used already. If it's around the design parameter, well, then you may use a higher rated component in that position to avoid that to get too close. If it's a poor soldering issue, you have to look at the soldering process in your factory line. Is the temperature profile right? Is the paste, the solder paste machine properly cleaned? Is the PCB maybe oxidized because it was stored in the warehouse for too long and the storage condition, there was too much humidity in there, all those kind of things. You know, we call it the 6M, that principle, according to the Ishikawa diagram. Can be the human, it can be the machine, it can be the measurement, it can be the material, it can be your design, your method, or it can be Mother Earth. But this is really normally not the case. But this is you really need to go down, and it's about diligence, it's about paying attention, it's about not ignoring it.
Yeah.
Yeah, I say arrogance is your biggest enemy in this case.
Arrogance on whose part specifically?
Yes, like a lot of time. Oh, it's somebody else's problem. I'm fine.
Yeah.
That's the worst part. You know, you need to be open. You need to embrace it.
Well, everyone has a manager looking down And so it's very easy, for example, manufacturer pass the blame to
Component
the
manufacturer,
component, and then they pass the blame back to this guy.
or to the designer.
So this is already, now you're dealing with people.
Yes.
And then, so I actually thought your business was machinery, engineering, but then there's a human component that comes in, and you also have to manage that.
This is the most important.
The most important.
Most important section. People make it, people break it. That's the principle of everything.
Yeah.
And the way you approach the people, the way you're dealing with the engineer, being respectful, being honorable, not being bossy, not saying, oh, I'm the king, I will do everything right. No, you also can do mistakes. Everybody can do mistakes. The designer makes mistakes, the manufacturer makes mistakes, the worker can make a mistake. Everybody. It's in the human nature that we all make mistakes. And creating a culture to take a failure not as a blame, but as a chance to learn and improve is one of the key elements of continuous improvement.
Right. And your team, I know you have, I'm assuming you have this culture in your team here.
Yes.
The challenge, I think, is when you're working with so many different other partners, manufacturers, clients, they don't always have that culture there, right?
No.
So then your job is actually affected by the culture of a manufacturer.
Yes, but the good news is mostly we are the customer of the manufacturer.
Okay.
So as I explained in the previous episode, the Chinese manufacturer typically listens to what the customer says. Yeah?
So you can actually pass on your culture to them.
We can, we try, we do our best. It doesn't always work, but give you an example. If you're a worker on a manufacturing line and you said, I want to have in my shift of the 8 hours, you have to get 200 pieces out, then you get full pay. If you only get 194 out, I will deduct 3% of your salary.
That's harsh.
And if the 6 pieces are bad because there's something going wrong, you will try to hide that because you don't want to get a salary cut.
And that's why you need to get.
And then you need to have somebody on the ground and say, no, so sorry. If you do not investigate that, I'm not going to accept those goods. Meaning you're not losing 3%, you're losing 100%. Because I want to know what these things and what you're going to do. And that corrective is crucial to improve the quality. Actually, it will also help the manufacturer, because if he solves the problem, he will not face the trouble whether he got 194 or 200 or 202 or 204.
Yeah.
But in the short term, the guy that's on the line that has to meet his shift target, he thinks very differently. So there's always this conflict of interest.
Yeah.
But being in the customer position is a much better position than being an employee position and working for the manufacturer.
Definitely. Yeah. And then now we're going from different cultures. For example, you might have your clients, customers in Europe. Then you have suppliers in China, Thailand, Taiwan. They all have a different culture, a different way of working, different languages.
True.
So there's so many variables.
Yes.
Yeah.
That's why in our team, everybody speaks at least 3 languages.
Wow.
Yeah.
And you were telling me you were having a meeting in Thai, English, and Chinese
Yeah.
today.
Yeah. And sometimes we have a Japanese man sitting in there. Then we add complexity.
Right.
So at the moment, we are experimenting with the AI tool from Microsoft Teams. And we have to say, in some languages it works well, in some languages still room for improvement. But yes, we also use this technology because when there's the 4th language inside, it's getting difficult.
Yeah.